Hello and welcome to another episode of TWiML Talk, the podcast where I interview interesting people doing interesting things in machine learning and artificial intelligence. I'm your host, Sam Charrington. To close out 2018 and open the new year, we're excited to present to you our first ever AI Rewind series. In this series, I interview friends of the show for their perspectives on the key developments of 2018, as well as a look ahead at the year to come. We'll cover a few key categories this year, namely computer vision, natural language processing, deep learning, machine learning, and reinforcement learning. Of course, we realize that there are many more possible categories than these, that there's a ton of overlap between these topics, and that no single interview could hope to cover everything important in any of these areas. Nonetheless, we're pleased to present these talks and invite you to share your own perspectives by commenting on the series page at twimlai.com/rewind18. In this episode of our AI Rewind series, we're excited to have Siddha Ganju back on the show. Siddha, who is now an autonomous vehicle solution architect at Nvidia, shares her thoughts on trends in computer vision in 2018 and beyond. We cover her favorite CV papers of the year in areas such as neural architecture search, learning from simulation, application of computer vision to augmented reality, and more, as well as a bevy of tools and open source projects. Enjoy. All right, everyone, I've got Siddha Ganju on the line. Siddha is a solution architect working on autonomous vehicles at Nvidia. Siddha, welcome back to This Week in Machine Learning and AI.
Thank you, Sam. It's been a great year so far, and thank you for having me once again.
Absolutely. So for folks that want to go back to your original podcast on the show, it was TWiML Talk number 95. At the time, you were at Deep Vision, but you've since moved over to Nvidia.
Yeah.
What will you be working on at Nvidia?
So at Nvidia, I'm focusing on a particular part of the entire self-driving stack, which is called simulation and resimulation, which is the part that does the testing and the verification of the entire perception stack. So how do we know that the computer vision, the LiDAR, the radar networks that we have trained, how do we know that they actually work well in real life? Because real life testing for autonomous vehicles is very hard to do because you can't test out the millions and millions of possibilities on actual roads with real test drivers inside the vehicles. So simulation is a developer-friendly way to do that. And it's also, you can squeeze millions and millions of miles. You can add tens and thousands of scenarios to simulate and test. So it's really a nice solution to testing.
And so you're joining us to represent computer vision in our year in review and predictions series. So let's jump right in. So you took the time to kind of prepare your thoughts on some recent some papers this year that struck you as particularly noteworthy in the computer vision space. Where do you want to start?
So before I start, I think I want to say that, I'm only human and I'm probably missing tons of game-changing papers that came out this year. And, through this discussion, we're probably just scratching the surface of this year's CV research. Now, that being said, I'm going to start with a couple of papers that are providing different solutions to problems rather than improving on existing tasks. So the very first paper that I really, really liked was called Learning Transferable Architectures for Scalable Image Recognition. And this is by Google Brain. Now, this is being projected as the future of deep learning. And the main reason behind that is because it introduces something called Neural Architecture Search, or NAS. So, Sam, you've been doing these podcasts, definitely more than 95 podcasts by now. And I'm sure during your discussions, a lot of people have talked about how designing a network architecture is a big pain point. And especially for those people who are just entering the field. So neural architecture search is really the beacon of light for them. It's a network that searches for the best model structure instead of you manually designing the network architecture. Now, internally, the search for this ultimate model is based on a reward function that rewards the model for performing well on the dataset it is being validated on. And at the same time, it's using the same metrics to validate and test the ultimate network. So I really like this paper because it details that such architectures achieve better accuracy than manually designed models. And searching also allows the network itself, a more brute force type coverage over the entire search space. Now, we can only imagine the huge benefits that a good NAS algorithm can give rather than hand designing a specific network for the millions and millions of specific applications that we might want to develop. So this is actually one of its biggest advantage, that it is generalizable. So a well-designed NAS algorithm is supposed to be flexible enough to find a good network for any specific task. And within the paper, they've outlined both detection and classification. So on ImageNet, they reported a 1.2% improvement in top 1% accuracy. And this is compared to what I guess we can now call the best human invented architecture. And the coolest thing is that this architecture has 9 billion fewer flops. Can you imagine the improvement in speed in real life production systems that we can get from this? I mean, NAS is bringing a whole new definition of real time. And on CFAR 10, I think NASNet achieves a 2.4% error rate, which is the new state of the art. And on the detection side of things, the features learned by NASNet from ImageNet classification combined with faster RCNN gives a new state of the art, which has a 4% improvement on the previous state of the art paper. So NAS is something really exciting, and I expect a lot of people entering the field to really go and test it out because it gives them a huge advantage of not wasting hours and hours trying to think of what is the ideal architecture for their specific application.
Did the paper talk at all about the training time to achieve that kind of performance relative to the training time for a single static architecture?
So when we talk about a single static architecture, it's not like we fix a single architecture and we stick to it throughout the experimentation pipeline. As a deep learning engineer, I often start with one architecture and go back and forth on every single aspect of that architecture to get to the final architecture that is put into production. So I think, comparing the times between what NAS will do versus what a single architecture does isn't really an apples to apples comparison.
And that's kind of what I was getting at. The training time to train a single ResNet or something like that on ImageNet, while it's decreasing, can still be, significant for some types of problems. And so I'm imagining that kind of searching through solutions like that is going to be even more complex. But you're saying that the comparison isn't really, against, just training, but also the time that that a human would typically spend in coming up with the architecture.
Absolutely. Yeah.
So that was the Learning Transferable Architectures paper. What else do you have for us?
Mm-hmm. Yeah. So the next one is from Nvidia, and it's called Training Deep Networks with Synthetic Data, Bridging the Reality Gap by Domain Randomization. So through this paper, Nvidia tries to solve an age-old problem, which is, can we pre-train with synthetic data for tasks that demand either expert knowledge or labels that were difficult to specify manually, or images that were difficult to capture in large quantities with, a huge variety and many such unanswered questions. So NVIDIA built a plugin tool for Unreal Engine 4 UE4 that simulates images for training data and uses that to train convolutional neural networks. Now, the biggest plus point is that all the factors spanning the main object, distractors, viewpoints, all these factors that the training data depends on are randomized and automated, making it so much more easier and useful to develop a dataset. So when we talk about the number, variety, texture of objects, the background, then for distractors, a huge variation in their number, types, colors, scales. For the camera, you can change the camera location, viewpoint, be it the virtual camera with respect to the scene, or the angle of the camera with respect to the scene, or the number and the location of point lights. And an interesting thing that they reported was that with additional fine tuning on real data, this network yields better performance than using real data alone. So, this result really opens up the possibility of using inexpensive synthetic data for training neural networks. I mean, imagine there are millions and millions of applications that don't have concentrated data collection efforts, or maybe, collecting data is just too difficult for certain types of applications. So such an example of using synthetic data for training would be a game changer in these cases.
Now, I remember hearing about papers that showed that synthetic data, wasn't all that effective at training agents that can perform in the real world. But results like this are changing that. Is that, has 2018 been kind of a key year in our ability to incorporate synthetic data into training, or is this paper building on successes that we've kind of seen in recent years?
I think in 2018, we had a lot of papers coming out on simulation or simulating data or synthetic data, and different papers tried out different techniques to how to develop the data. How do you, for example, change the surface of or the material of an object? How do you make sure it looks different from the background? So there are a lot of papers in this synthetic data field coming up, and a lot of them achieve good results. And I was talking about this one because they've made it so much more easier and useful because they have a plugin tool. They've got so many options to change from, for example, the object, the background, the distractors, the viewpoints. It's, if you can imagine a Photoshop kind of a generator that that can spit out image frames based on how you're coding it up. It's really similar to that.
So what's next on your list?
So this is a really fun but extremely amazing piece of research, and it comes from University of Washington that makes for more commonplace AI applications.
Okay.
And it's called Soccer on Your Tabletop. So they've developed a system that takes as input a YouTube video of a soccer game, and the system outputs a dynamic 3D reconstruction of the game that can be viewed interactively on your tabletop with an augmented reality device. So, how people right now watch matches on their mobile devices, tablets, laptops, television sets, and so on. Imagine watching it on your dining table, your work table, your kitchen counter, literally everywhere or anywhere for that matter. So this system is really multimodal. They are combining different types of information, for example, bounding boxes, poses, trajectories, all extracted from the player to segment them. And these 3D segments are projected onto any plane, which becomes the virtual soccer field. And they've released an example video of this and on YouTube. And it's really cool. And I encourage all of you to check it out. It's called Soccer on Your Tabletop.
Oh, that sounds incredible. I'm amazed that I haven't come across that video.
Yeah, you should definitely check it out now. So the next one, let's talk a little bit about vision, and language coupled together. So before we talk about the papers, I think it's worth mentioning the second edition of the VQA challenge dataset, VQA 2.0, which actually was released in 2017, but it's worth talking about it because it was a much more balanced data set and it reduces the language biases over VQA 1.0, and it's double the size of VQA 1.0. So the very first paper in VQA is learning to count objects in natural images for visual question answering. This is by Yan Zhang and others. So this paper focuses on developing a counting solution for VQA, and they use mostly attention for that. They've proposed a differentiable counting component which explicitly counts the number of objects based on a hand-designed architecture using a graph of object proposals and non-maximum suppression. So it's basically just applying non-maximum suppression on object proposals and counting the number of objects that are within the image.
And what is non-maximum suppression?
So it's an algorithm for mostly used for detection. So this method improves the baseline by about 6.6% on the counting questions. And I don't remember the statistics in VQA 2.0 dataset, but in the VQA 1.0 dataset, counting was a very big problem and it was extremely biased because most questions, for most counting questions, the answers was usually 2. So boosting a baseline by 5% is huge. So I really like this paper for that.
And so with this paper, is the idea that this model that they've developed for counting would be used as kind of like a submodel for a broader VQA system?
Yes. So I was actually coming on to that. The next paper, which is Bilinear Attention Networks for Visual Question Answering, they have integrated the counting module that we just talked about from Zhang. And along with that, they've introduced other techniques to improve their VQA accuracy. And this paper is called Bilinear Attention Networks for Visual Question Answering. It's by Jinhua Kim from Seoul National University. They are using the counting module. They are also using bilinear attention, which is the interaction between the word and the visual concepts. They also have a low rank bilinear pooling, and they have residual learning with attention mechanism for incremental inference. That sounds a lot. And I think, I'm not sure, but I think this was among the top VQA 2.0 winners. And then one paper that is, or one model that is right for the right reasons is Women Also Snowboard, Overcoming Bias in Captioning Models. So they've introduced a new equalizer model that encourages equal gender probability when gender evidence is occluded in a scene, and confident predictions when gender evidence is present. So they're basically forcing the resulting model to look at the person rather than use contextual cues to make a gender specific prediction. Mm-hmm. And they've also introduced two kinds of losses, which is the appearance confusion loss and the confident loss. Both of them are generalizable and they can be added to any description model in order to mitigate the impacts of any unwanted bias in the description dataset. And when we talk about the results, this research achieves two things. They get a lower error than existing work when describing images with people that mentions the gender, and it much more closely matches the ground truth ratio of sentences that include women to sentences including men. And the second achievement is when we visualize the results, we see that the model is actually looking at the people when predicting their gender, which is really important because a lot of visualization results, they don't necessarily focus on the people when they are predicting the gender. So this was a really interesting find by this paper. Women also snowboard, overcoming bias in captioning models.
Oh, that one sounds really interesting.
The next one is weakly supervised photo enhancer for digital cameras. So I think, Sam, you enjoy photography, right?
I do enjoy photography, especially digital photography.
Yeah, so this one I hope you find interesting because they've trained a generative adversarial network to improve the aesthetic quality of standard or normal looking photos. So let's say I take really bad photos and I put it in this generative adversarial networks, and it comes out looking completely professional looking, applying the rule of thirds, improving lighting, having enhancements that you get from image editing softwares. And there are two cool parts about this. The first one is that they're using GANs. So you don't need a pair of good looking and bad looking images. You only need a set of good looking images and a set of bad looking images.
Mm-hmm.
And the second part is that because it's weakly supervised, the pair of input and visually enhanced images isn't necessary. So there are these two really cool things about this paper on GANs. And if you look at the results, they are, GANs have become so photorealistic that it's just, it's crazy to imagine that GANs were once spitting out what that was, not as aesthetically pleasing. But now when you look at these images, it's just amazing.
Yeah, the original images that you see with GANs are like these kind of grotesque approximations, and now the celebrity work that Nvidia did, I think that was earlier this year or maybe late last year. And there's one that's been going around even more recently, the photorealistic images. I mean, it is getting quite incredible what they're able to do.
Absolutely. So another paper that I really like is called, no, this is a really long name, so bear with me. So it's called Efficient Interactive Annotation of Segmentation Datasets with Polygon RNN. So this is an interactive annotation tool. Now, if we think about labeling of datasets and we talk about segmentation data, we know that class labeling needs labeling of each and every pixel in the image. Now, this is quite literally forever if you're talking about millions and millions of images. We know that deep neural networks work well when they can feast on a large and fully annotated dataset. So this paper is really the economical bridge between these two worlds, because with Polygon RNN, you can set rough polygon points around each object in the image that you want to annotate. And then the network will automatically generate the segmentation annotation. And a big advantage is that a method generalizes well, so it can be used to create quick and easy annotations for segmentation tasks.
So is the idea here that typically for image segmentation, we want this to be on a pixel by pixel basis so that we can kind of train a network very accurately. But what this is doing is allowing someone who's doing segmentation to just do it on a polygon basis, and then the network will map that to, we'll kind of find the more accurate pixel based segmentation.
Yes, that is the idea. But it makes the process of annotations much faster.
Right.
Because you don't have to go pixel by pixel, right? You only have to give a rough polygon, and then the system will adapt the polygon to the actual the edges of the object.
Mm-hmm.
Yeah.
And do you have a sense for this? How close do you need to get? Do you still need to get within a few pixels? Is it meant to be kind of a fine tuning mechanism, or can you kind of very roughly put a polygon around, say, a person in a picture of a street scene?
You can make it pretty rough. I mean, in their examples, they've shown aerial imagery, and those examples are pretty neat.
Huh, interesting. Cool.
Yeah. I've got two more that I really like.
Okay.
Okay. So this one is super slow-mo, high quality estimation of multiple intermediate frames for video interpolation. And this comes from University of Massachusetts at Amherst. So you're given two consecutive frames and they apply a method of video interpolation that aims at generating intermediate frames that are both spatially and temporally coherent sequences. So internally, it's utilizing optical flow and convolutional neural networks between frames to interpolate video frames input at 30 frames per second. And it produces crisp looking results at 240 frames per second. And they've shown examples of like a bullet going through an egg. And, you know, to a human eye, you don't really notice much. But when you look at it in super slow-mo, it's really breathtaking. I mean, you can see how the cracks on the eggshell propagate, and that's really cool.
Oh wow.
Yeah.
Wow. And they're doing this from
Optical flow and CNNs.
Right. Are they training against slow-mo data, or is this interpolation happening without specific training in that way?
It's got training.
Okay. So the network kind of learns what the effect of slow-mo is from slow-mo training data, and then can apply that effect to non-slow-mo video.
Yeah.
Okay. Very interesting. I mean, between this and the GAN-based photo enhancer, you can start to see how some of these techniques can work their way into our everyday devices.
Applications. Absolutely. And that's actually a really good point, because handheld devices now have GPUs in them. You know, they have separate accelerators that accelerate CNNs. So, you know, I guess even the mobile industry is expecting developers to use these techniques, because they're putting these heavy GPUs inside these devices. And this all started, I think, in 2015. So if you go around benchmarking all these devices, you notice that in 2015 there is a sudden jump in hardware acceleration, and that is when these GPUs were introduced into mobile phones.
Okay.
So I'm really excited for all the new applications that are about to come.
Yeah, same here.
Yeah.
So you have one more paper.
Yes. Now this is called Who Let the Dogs Out? Modeling Dog Behavior from Visual Data. And this comes again from University of Washington.
Okay.
So I remember when this paper came out, I found it through a YouTube recommendation. And a dog was walking around with all these sensors, a GoPro and Arduino attached, and a number of sensors on the dog's limbs. And they'd linked an archive paper with it. And I was really fascinated by, what is this dog doing on archive paper? And then I read it, and it's very interesting, because when we talk about visually intelligent agents, we tend to break that into smaller, more approachable subproblems like classification, detection, and planning. But this paper conquers it as a one big problem. So it takes input images and it produces planning actions. And again, the data collection is from a dog using a GoPro, Arduino, and a number of sensors on the dog's limbs. So they've got feature extractors from CNNs, which they use to get image features from the video frames, of course. And then all of this is passed to a set of LSTMs along with the sensor data. And the system learns and predicts the dog's actions. And in the paper, they've exemplified three particular tasks. One is acting like a dog. So you have a previously seen sequence of images, and you want to predict what will be the future movement of the dog. The second task is planning like a dog, where you have a sequence of a source and a destination locations. And the goal is to find a sequence of actions that take the dog from the source location and the destination location. And the third and the final task is learning from a dog. So can we learned representations for a third task? For example, if I'm a dog, can I try to understand if the surface in front of me is walkable? So stuff like that. And I think this paper is really interesting because it's like an end-to-end solution, not it's not breaking up different tasks like planning, detection, or classification. It's really treating it as one big intelligent agent. And I haven't seen those examples in a really long time. So I think that's why this paper stands out so much.
I'm thinking of applications of this kind of paper, and the thing that jumps out at me is, when you think about these Boston Dynamics robots, how they might,
Yeah.
this kind of training might, help them get to something that's more intelligent.
So the Boston Dynamics robots are really, they've got four limbs and like a upper body part and then a sensor network of cameras and so on. But when I think about this paper, I think that it's not only applicable to like the Boston Dynamic robots, but generally all robots, because planning, action, learning, coupling with understanding of the outside world, all these are, very essential parts of the visually intelligent agent. And it's not just a single robot that can benefit from it. I mean, this system could be easily applicable in phones, for example, for helping blind people or um, for the deaf community in certain cases. So it's really exciting to see how end-to-end applications are developing and coming into real life.
Definitely some interesting papers from 2018, and particularly with your caveat, this is just the few that came to mind as
Yeah.
particularly meaningful contributions, and related to the kind of scope of the elements of the field that are of most interest to you.
Yeah, and I think I've already said this, I don't know how many times, but the speed of publications is just immense. And the good thing is that it's all quality work that's coming out. So keeping up with all of this is so much more challenging than it used to be before.
One of the things that we wanted to talk about was kind of your perspective on the different kind of research accomplishments of 2018, but that's been difficult for you. You said there's so many interesting papers in 2018.
So here's an idea. We know that there are different stages in the AI pipeline, like data collection, labeling, training, and so on. And then there are some new entries like model reproducibility, fairness, and biasing. And so why don't we sort of use these stages as a demarcation and in each talk about papers and tools and new research that have come up?
Oh, that sounds great.
And again, I think like you've been doing for all TWiML AI talks, we will try to link all the tools and use cases so people can read about them a little more. If we consider data as the new oil, then labeled data really becomes the new gold. And that brings us to our first category, which is data collection and labeling. So AWS released something called AWS Deep Racer, which is a small scale race car that gives you a fun and an interesting way to get started with reinforcement learning. So, as we all know, reinforcement learning takes a very different approach to training models than other machine learning techniques because it learns complex behaviors without requiring any labeled training data. And at the same time, you can make short term decisions while optimizing for a longer term goal. And especially with AWS Deep Racer, you can get hands on reinforcement learning. You can do a lot of experimentation with cloud based 3D racing simulators. You can race your friends all while dipping your toes into autonomous driving. I think AWS Deep Racer really comes out as a top new tool that Amazon has released this year.
Yeah, I was at reInvent last week when they announced it. And they also announced a new extension to their SageMaker tool that's focused on reinforcement learning. And I'm really glad you brought up RL in this context. I think, when I think about the work that OpenAI and DeepMind are doing around reinforcement learning, for those organizations, I think a lot of their motivation is that we kind of, as humans, kind of learn in a reinforcement learning way. We don't have labeled, training data. We kind of explore our worlds and learn. And so they are aggressively pursuing reinforcement learning as a stepping stone to AGI. But I think for most of us, the practical implications of RL are that it kind of gets us, it sidesteps this need that we usually have for labeled training data. And in the near future, that's going to be its big contribution.
Yeah.
So, and I'm particularly excited that, AWS, which has so much weight in this space, is starting to kind of shine the light on reinforcement learning and get people, starting down the path to experimenting with it.
Yeah. And now that you've mentioned, going into the future, how will we have labels available? There's work done by the Microsoft machine learning team and the Apache Spark community, and they actually worked on creating a deep distributed object detector that works without any human labeled or human generated labels. Now, if anyone who has ever trained their own detector knows how incredibly painful it is to get the bounding boxes and the labels right. But now, thanks to a technology called LIME, we can work without any data. And LIME is local interpretable model agnostic explanations. And this was built by Marco Ribeiro and a team from University of Washington. And it helps in understanding the classification of any image classifier. So it's really telling us where the classifier is looking. And then here's the coolest thing ever. It makes no assumptions about the kind of model. So you can use it for your own secret model, random published models that you downloaded from the internet, or even a very patient human classifier, which means that it has extremely wide applicability, not just across models, but also across domains.
So Lime was originally published a few years ago, I think, but you're saying that folks are now using it to, beyond its initial intent of model explainability, but to allow you to create classifiers without labeled training data?
Yeah, so I was actually coming to that.
Oh, okay.
So Lime has a huge drawback that it is extremely computationally intensive. So what the Microsoft machine learning and the Apache Spark community did was they made this available in a distributed implementation in Spark ML. And that's how you can make it more real time. And because of that, you can create image classifiers for classification or detection from bounding boxes. And they experimented with this on a real life use case for the conservation of snow leopards in Kyrgyzstan. So that was pretty interesting.
And so can you give me a sense for how that use case works, or what the flow is in working with this tool?
Yeah, so it's basically you have all this data which is not labeled. So you have plain basic images, which can be without the actual object, which is a snow leopard in this case, or it can include the snow leopard. Then you run Lime over all these images, and then you ask simple questions like, what is the most common object that you're seeing over all the data? Where is the object located in most of these images? And that's how the system really learns what is most common, what it should be looking for. And once you have these questions answered, you can use that as sort of like a a label, but without any human actually working on labeling. And then you can generate the entire system of object detection with that.
Oh, interesting.
Yeah. And then again, all of this is real time, it's distributed, so it's pretty quick. And if I remember correctly, they had a statistic in their published work, which was that if it takes 1 hour for you to evaluate your model on a particular data set, then it would take 50 days worth of computation to convert these predictions to interpretations. And now that doesn't sound attractive at all. And that is where the improvement is coming, by making it a more distributed implementation and packaging it in Spark ML.
Okay. Very cool.
Yeah. Yeah. And then a Christmas miracle is when we talk about labeling, is two companies, Digital Divide Data by Jeremy Hockenstein and Samir Rena, and iMerit. Now, both these are nonprofit companies that provide labeling solutions. But when I'm talking about it right now, it probably sounds like the million other labeling companies out there. But here is really where their heart is. They train and employ people who have no other sources of employment, and for the most part, don't have access to higher education.
Mm-hmm.
These people learn by doing, and they earn enough money to support themselves and eventually hone enough skills to go for certifications or undergraduate cases. And I think Digital Data Divide mentioned that they have uplifted more than 3,000 individuals, their families, and communities all around the world. So that's pretty interesting.
Oh, yeah.
When we talk about labeling in terms of how it's really impacting the world.
Mm-hmm. It's interesting. We talk a lot about AI for social good, and it's usually we're thinking about the AI itself, but now this is an example of how even the process of creating AI can be beneficial to communities.
Yeah, I mean, imagine what these people can achieve in the future. It's just limitless. And then there is another tool called Prodigy, which is helping solve a really big issue. Now, we all know that the AI workflow doesn't really follow a waterfall development strategy. It's more like a chicken and egg problem, because you can't really start experimentation until you have at least the first batch of annotations. But the annotation team can't start until they receive the annotation manuals. And to produce the annotation manuals, you need to know what statistical models you need based on the features you're trying to build. So, all in all, machine learning is an inherently uncertain technology, whereas the waterfall annotation process really relies on accurate and upfront planning. So, what Prodigy does, honestly, living up to its name, it solves this problem by letting data scientists conduct their own annotations for rapid prototyping. It puts the model in the loop so it can actively participate in the training process and learns as you go in an active learning kind of a setup. It has A/B evaluations and a whole suite of tools to help you prototype much faster, bringing in the much needed increased agility. And what's really awesome about Prodigy is that it's written by the authors of Spacey, which is a really cool NLP library.
I've heard quite a bit about Spacey, and so what's the user experience of working with Prodigy?
Prodigy is extremely efficient. It's got, you can use it via command line. It's also got a beautiful UI support. It helps in both annotation and training. And I've tested it out for detection problems. And it's really easy to, get like 10, 20 images, define what object you want to detect, give a few bounding boxes, and see how the model predicts the bounding boxes on the next couple set of images, and then use those as a bigger data set for training.
Huh, interesting. That sounds like it would take a lot of the early effort out of kind of experimentation. I remember going through the fast.ai course, and this whole process of like searching for images on, like Google Images, and
Yeah.
labeling them and putting them in the right in the right folders, and all this stuff can be pretty time consuming.
Yeah, that's true. And what's even better is because it's got an active learning setup, it can figure out which of the following images is something that, if it's included in the training data set, it will perform better rather than, adding images that don't really improve the accuracy.
On that note, AWS announced something in the same vein at reInvent, SageMaker Ground Truth, which uses active learning in the same way. It basically is a labeling pipeline that incorporates human-in-the-loop labelers, which can be Mechanical Turk or some of their partners. Maybe some of the companies that you previously mentioned are included in that. They also use active learning to try to make the labeling process more efficient by only labeling the images that will... Actually, I don't even recall if it's specific to vision or if it's broader, but only labeling the kind of the data that will add the most value.
That's true. It's definitely available in AWS now. It's also been, if I'm not wrong, available in Google Cloud from their AutoML team. And internally, they use Crowdflower, or what is now known as Figure 8. And that also employs a method of active learning, if I remember correctly, and hopefully I am. But yeah, so active learning for labeling has been, a top priority, I think, for companies this year. At least that's what it seems like to an onlooker.
Agreed.
Yeah. Yeah. And then a really interesting trend that's up and coming is gamification of labeling, which keeps the interest going in human in the loop labeling. So what you do is, you put these certain objects that you're looking to detect or classify at really weird places that you wouldn't expect. And we know that convolutional neural networks, they depend not only on the object, but also on the usual surroundings of that object. So it kind of, focuses the network to try to concentrate on the object itself rather than its surroundings, because you are getting so much variation in the surroundings. My co-author Anirudh actually talks about this in his TEDx talk, and it's really interesting to see how companies are incorporating gamification in their annotation cycles.
And so is this gamification for human labelers, or gamification somehow trying to game the neural networks themselves?
So it's kind of both, because you are looking for these certain images that will not work as well because the object isn't in their natural environment. So that's one. And then second, it also keeps the interest of the human labelers really ongoing in the system, because they are so familiar with the system. They know how to break it, what are the kind of images that will really break the system, because they are the ones who've gone through the entire data distribution that the model really depends on. So it's a bit of both.
It's interesting. It makes me think of the humans and the network in some kind of adversarial relationship, separated by distance and time.
Yeah, I mean, I actually think of it the same way.
Interesting. I think we should move on to your next category to make sure we can get everything in.
Okay, awesome. So the next category would be training. And training, I think there have been a lot of frameworks which have come out which help to do hyperparameterization, which help in maintaining like a GitHub equivalent of the entire training cycle.
Okay.
And then moving on to an open source experimentation optimization library, which is called HyperOPT. It's a distributed asynchronous hyperparameterization optimization library in Python. Um, and it does both serial and parallel optimizations over search spaces, which can be real value, discrete, and conditional dimensions. But HyperAS is actually a very simple, convenient wrapper around HyperOPT for faster prototyping with Keras models. And I think HyperAS is something that I feel, it can really be a game changer, because a lot of people, when they start in deep learning, they don't really learn about how do you actually tune the hyperparameters, what is the initial value at which you want to start. But with HyperAS, you can define an entire hyperparameter range, and then internally it will learn which is the best value for each particular parameter. And this is really the only difference or the only additional thing that you would have to do, apart from just defining your model as you already do in Keras. And then you can also run multiple models, training, testing in parallel while using MongoDB as a backend. So HyperAS has become really cool, I think, for companies, that are really looking for a small scale solution.
Interesting. Yeah, one of the other things that I've repeatedly seen as a best practice in this experiment management category is automating hyperparameter optimization. I think a lot of people think of that, or historically have thought of hyperparameter optimization as this, the cherry on the cake or the icing on the cake, or something like the thing that you do last to kind of eke, a few more percentage points or a few more points of accuracy or performance out of your models. But all of the folks that I'm seeing doing this bake it very deeply into their experimentation pipelines, so that you're really automating this optimization throughout the whole experimentation cycle, as opposed to kind of just at the very end. And if you parameterize your models correctly, the hyperparameter optimization can help you kind of define and evolve your architectures as well. So another product out in this space is SIGOPT, who is a sponsor of this Agile Machine Learning Platforms ebook that I referred to earlier. And they've also been, they've presented at the TWiML online meetup, I think that might have been last year, about some of the things you're doing. But I definitely expect to see a lot more folks working with hyperparameter optimization and kind of building it deeply into their pipelines.
Yeah. And another thing interesting to note here is that 2018 has been a year of neural architecture search, and combining that with HyperAS is just taking training and optimization to a whole new level, because you're not only optimizing the parameters, you're also optimizing the entire architecture, which is, architecture definition is always something that it's really difficult to get right, and you never know, is this exactly right, or if I remove some layers, will it still be the same? So that's a problem that I don't know if there's any solution for it, but neural architecture search is definitely amazing. It's absolutely stunning how they've been able to achieve it, and its results are amazing.
Yeah, there was a period of time on the podcast where I would ask every guest in this space, like, how do you come up with architectures? Where do they come from? I probably asked you this. And the conclusion that I came to, a year ago, a couple of years ago, was that, it's a little bit of black magic. Like, people just try a bunch of things and see what works. And I think what's interesting about what we're seeing now with the neural architecture search is that, we're bringing a little bit more of science and methodology back to it.
Yeah. It's a little more of, the software engineering techniques that we've all been learning and incorporating those into the AI development cycle.
Right.
Yeah. And I think another tool that's worth mentioning is Rapids from Nvidia. So, we talk about how training has been accelerated by GPUs, how for inference, you have different kind of GPUs or different kind of hardware on which you want to do inference. But NVIDIA's Rapids is really a suite of software libraries that allow the execution of the entire end-to-end data science pipeline entirely on GPUs. So it can be data processing, training, testing, loading, anything. Everything is inbuilt onto GPUs. And of course, internally, it's using CUDA primitives for low-level compute optimization, and it exposes the GPU parallelism that we all love. And it's got really high bandwidth memory speed. It exposes very easily usable Python interfaces. And because it's been focusing a lot on data preparation, which I know is a really, I've been struggling with data preparation. How do you load such heavy data when you know that this data set won't fit into memory? So, these kind of problems that people face every day, NVIDIA Rapids has actually a solution to it because it's introduced the data frame API that integrates with existing machine learning algorithms for the complete end-to-end pipeline acceleration. And, you forego the serialization costs, which you would have to endure otherwise.
I came across the Rapids announcement, which was relatively recently, but never quite had a chance to dig into it and see what they're doing. I don't know if it was Rapids or something else, that one of the big points about it was that, we kind of think about GPUs as, having being primarily useful for neural networks, but they went ahead and created GPU accelerated versions of a bunch of traditional machine learning operations.
That's exactly Rapids.
Okay.
Yeah. And then, it's also available for multi-node, multi-GPU deployment. So, if your work is scaling up, Rapids is the best, set of software libraries that you can use to scale up, down as your requirement changes.
Mm-hmm.
When I think about when I started off learning about machine learning and deep learning, I think we didn't have anything like this. And, today I feel like, people have so many sources to learn from. And, be it fast.ai, Kaggle, or deeplearning.ai, or even Siraj Raval's School of AI, there's just so much to learn and so much to do that I feel 2019 is going to be a year of, every single day there's going to be something new. Because
it seems like that sometimes, doesn't it?
Yeah. I mean, sometimes it feels like, we're on an episode of Silicon Valley, because every single day something is coming up, and one day it's the state of the art, and the next day there's another state of the art.
Mm-hmm.
And then we have testing and deployment. And I honestly feel that, as a member of the AI community, testing and deployment have become really even though there's a lot of focus on training, testing and deployment have become even more important these days, because that's where things are actually in production. So, for example, if you talk about Onyx came a couple years ago when Facebook and Microsoft said, why do you want to limit yourself to only one framework? And we want to promote model interoperability. So Onyx came through. And now if you look at the benchmarks for Onyx.js, TensorFlow.js and Keras.js are not even in the standing when it comes to how ridiculously fast Onyx.js is. And, all this comes through years of research and experimentation when we realized that, we want to build smaller models. When the model size is smaller, you can have smaller image sizes. You can use the inherent hardware acceleration in JavaScript. And, literally within the snap of a finger, you can have an entire batch of images tested and predictions made on. And now that we're actually talking about browsers, I have to mention the amazing work by Oz Ramos, who is using OpenPose to track eyes to help navigate through a browser. And of course, there is a limit to how much is possible, but imagine the benefits that people with impairments can reap from this. And the inspiration behind Oz Ramos working on this is also really encouraging. And, he was a veteran who sadly lost his home. And, he was seeing people around him who weren't really capable physically to, use their systems or laptops or desktops. So he decided to use an eye tracking software to actually help people navigate browsers and so on. And I believe he's on Patreon, and he's doing a lot of cool and interesting work.
So maybe switching gears a little bit, I'm curious what you foresee for 2019 in computer vision.
A lot of people are expecting GANs, to really be in videos, for example. I mean, this is more evolutionary rather than revolutionary, because when you look at the current state of the art, GANs have achieved almost photorealistic results, and it's just amazing. And I can't wait to see what's next with GANs. And hopefully it's going to be something in videos.
Mm-hmm.
And then in robotic perception, because we know robots are really good at doing only one thing right now. But when we talk about general understanding, they don't really work as well. So, this is where visual understanding, scene understanding, sort of like a multimodal input comes in. And it would be really interesting to see how perception systems, or, how the human AI interactivity takes off. And then I think utilizing AI in other fields, for example, NASA's Frontier Development Lab had a really amazing year this year. I'm looking forward to see what happens next year in their work in astrobiology, detecting meteors, asteroids, and so on. And then in healthcare, AI is really useful, and in particular, computer vision is really useful for both, learning about healthcare and for patients as well. So when you're learning about healthcare, for example, you can learn or you can visualize how the heart is pumping the blood. You can visualize all the different valves in the heart and see how the pulmonary veins and the pulmonary arteries are sending blood to the lungs and getting it back to the heart. That's really something that is absolutely revolutionary. And imagine how the entire education system would change with just these simple applications.
Right.
And then, I have to mention this. Most of my friends have actually stopped buying cars and are instead leasing, and they're waiting for 2021 to come by to experience self-driving cars. Imagine, you're calling a Lyft or an Uber or a taxi and it's self-driving. I mean, that would be so cool.
Yeah, it's funny. I was having a conversation with a friend about kind of this idea that, we may be the last generation for whom, buying a car is a real thing.
Yeah.
And increasingly, we're kind of entering this domain of, more transportation as a service, whether it's, summoning a vehicle from someone else's fleet or leasing a self-driving vehicle, maybe one per family, and the vehicle's kind of always doing something for someone, as opposed to, most cars
being
sitting
free.
around, waiting
Parked.
for you to finish work or finish whatever you're doing.
Yeah. Yeah, I mean, it's really interesting, I mean, no one really knows what the future is going to be like, but it's really interesting to, think about it. And I think it becomes even more exciting when you're actually working on it, and, you see the perception that different people have regarding it, and you realize, we can do this to improve the system, or, this feature would be a really cool thing that people might even love.
Mm-hmm.
Yeah. So another thing I think that would be really exciting is development around zero-shot learning, because we all realize that academic data sets are really good, but real life deployment is very, very difficult. And some sort of practical application would be really interesting around zero-shot learning. And um, a couple more things around reproducibility and fairness and biasing. So the number one thing I think is going to take off and is really the need of the hour is model cards, which is a revolutionary piece of research that comes from Margaret Mitchell and her team at Google. So model cards are like short book reports for training machine learning models that provide benchmarked evaluations across different kind of conditions like cultural, demographic, or different kind of intersectional groups, which are all relevant to the intended application domain. So they also disclose the context in which the models are intended to be used, details of how the performance of the model is evaluated, and other relevant information. So, in 2 years, when people will be freely communicating through models, it will seem insane that it's not standard to report how well machine learning models work when they're actually made available for general public use. And I can see model cards really taking off in this aspect.
Yeah, it's interesting. Over the past year or so, many of the large AI, many of the research arms of the companies that are biggest in AI. I'm thinking specifically about Microsoft Research with the data sheets for data sets work that Timnit Gebru worked on.
Yes. Yeah.
IBM Research did a extension of that concept, which sounds very similar to the model cards work you're describing. But none of these companies are publishing any of these, data sheets or model cards for their commercial projects yet. That's definitely something I hope to see them do, kind of putting their money where their mouth is, so to speak, in 2019 or 2020.
Yeah, and especially given the fact that we have these like a model exchange service that has really come up this year. For example, TensorFlow has TensorFlow Hub. So you have some piece of reproducible code, reusable code that you use in most applications. For example, if I want to write some code to load a large piece of data and I don't know how to do it, I would look it up, find something on GitHub or Stack Overflow, and reuse that code with the appropriate references. And TensorFlow Hub really makes this much more easier because they've set up a library that has these small snippets of reusable parts of machine learning code. It's published, it's easy to discover things that, are efficient and, just really use the best that's available out there rather than, spending hours of your time actually trying to figure it out yourself.
Mm-hmm.
And then similar to this is Model Depot, which is a place where you can find and share optimized, pre-trained machine learning models that are perfect for your development needs, similar to what Model Zoo was before.
Okay.
Yeah.
Interesting. So we're running low on time. Any final thoughts or predictions before we close out?
I guess, I'm looking forward to the day when we will thank AI for taking away our workaholism and then let us get on with the job of being human. I mean, that would be pretty cool. Yeah, I guess, we talked a lot about different tools, different research projects that have come up in different parts of the AI pipeline, how these are applicable in real life examples. So, I mean, it's been a pretty eventful year, and I can't wait for 2019 and, see the downpour of publications come on one by one.
All right, Siddha, well, thanks so much for once again kind of spending the time to kind of go through this stuff with us.
Thank you.
All right, everyone, that's our show for today. For more information on Siddha or any of the topics covered in this episode, visit twimlai.com/talk/218. You can also follow along with our AI Rewind 2018 series at twimlai.com/rewind18. As always, thanks so much for listening, and catch you next time. Happy holidays.